I'm not just going to say, here's what's on the test and go after it. I want to go over every single property, right, to make sure we are good. There's not many. Back years ago, we used to do this over 2 days, this test. There's a ton of material, but we chopped it all down and said, all right, we're only going to do 42 points, 2 proofs, right, 1 coordinate and 1 regular statements reason. So I wouldn't focus on the proofs too much. But I will guarantee this. I will ask at least 1 question on all the quadrilaterals. Okay? I will at least ask 1, if not more, on all the quadrilaterals. You're going to need Pythag. Eventually, one of the questions or more, you're going to need Pythag. And I just have a reminder here that, yes, this unit's been on quadrilaterals, but day 1 was not. That's on your interior, exterior angles. All right. So what I'm going to do right now is we're going to go through all the properties to make sure we're all set and not forgetting anything. All right. I'm not asking you to copy them down at all. If you want, great. If not, everything's in your packet to begin with. So let's first start with that interior and exterior angles of a polygon. That was day 1. There's a formula for the sum of the interiors, and that is 18. That's a good start. I'm feeling confident already. Feeling confident for tomorrow. 180 times n minus 2, and n represents number of sides. 18. Here we go. Sum of the exterior angles. There is no formula, right? Because it's always 360 degrees, no matter how many sides it has. All right. Next up, how about parallelogram properties? Should be 5 of them you roll in with tomorrow. Just that's what we did third period. Just bark them out here. Opposite sides congruent. Opposite sides parallel, which means if there's a diagonal drawn in, look for what type of angles? Alternate interior. What else about a parallelogram? Let's roll. Let's roll. Opposite angles congruent. Oh boy, that's it. Consecutive angles, supplementary. There's a lot here. I warned you. Charlie, what's that last one? Yep, diagonals bisect each other, which means they meet at each other's midpoint, which are the same. Yep, they meet at each other's midpoint. Diagonals bisect each other. All right, good deal. How about a rectangle? Rectangle properties. I'm going to start with all those. Don't forget it. All those parallelogram properties. And then what are the special ones that only a rectangle has? All right angles. Yep. And diagonals congruent. And I had you guys write down a 4th one, which kind of mixes in these 2 here. If they're congruent and bisect each other, all 4 of those pieces are congruent, which means they form diagonals form for what type of triangles? Isosceles triangles, yep. Okay, diagonals form, sorry. All right, rhombus. Rhombus.
All sides.
Yep, hold on. I'm still going to write parallelogram properties. All sides congruent. Keep rocking. You got 2 more. Diagonals perpendicular. And that's when I can see you guys using the Pythagorean theorem, because all 4 of those triangles, when you draw the diagonals in, are right triangles. And then something else about the diagonals. They're perpendicular and they are angle bisectors, right? Okay, diagonals are angle bisectors. All right, let's keep trucking. There's a lot. Hopefully this is waking some of you up for tomorrow. Square. All properties, right? All rectangle. all rhombus. All right, trapezoid. Only one. I didn't say isosceles, I just trapezoid. One pair.
Opposite, base sides parallel.
There you go. I don't know what that was in there, Doyle, but yes, one pair of opposite sides, which we call the bases. Yep. One pair of opposite sides parallel. Yep, that's it. I'll get to mid-segment in a second. How about isosceles trapezoid now? Base angles congruent. And remember, there's two pair, two at the bottom, two at the top. And legs congruent. Yep, the non-parallel sides are congruent. And then finally, diagonals are congruent. Yep, and that's it. I get fired up about that. Nothing else about the diagonals is true in isosceles trapezoid, just that they're congruent. Nothing else is true. Let's go back. Mid-segment. I'm sure I'll ask a question about a mid-segment. We took a lot of time in class to talk about that. Where's my trapezoid? There it is. All right, how's a mid-segment formed? You connect the midpoints of the non-parallel sides. So here's my mid-segment. All right, what do we know about it? 2 facts about a mid-segment going into tomorrow. It is parallel to the bases. So look for same side interior angles being supplementary. And how do you find the length of it? Yep. Half of the sum. It's half. Take the sum of the bases and cut it in half. There's your mid-segment. Oh, we're forgetting somebody as usual, right? The other side of the tree. The kite, but it's going to be on there. There's properties, right? First property, 2 sets of adjacent sides that are congruent. What else? What do we have? One pair of opposite angles congruent, and then where did we say those angles are located? Where the non-congruent sides meet. So in this, I just don't want you to think left and right, because if I turn this thing 90 degrees, it's not the left and the right anymore. It's in between the 2 non-congruent sides. All right, what else? Hey, what else?
Diagonals from right angles.
Diagonals perpendicular. Yep. And one other thing about those diagonals. There you go. Diagonals perpendicular. Longer diagonal bisects shorter. Woo! It's a lot of properties. We just went over a lot. Also, what I would have in mind before you come in tomorrow, because there is one coordinate geometry proof, you go through each figure and you say to yourself, if he's going to ask me to prove a parallelogram, how am I going to do it? Am I going to do opposite sides parallel with slopes? Am I going to do opposite sides congruent with distances? Make a decision before you come in tomorrow. If he asks me to prove a rectangle on coordinate geometry, how am I going to do it? What's my go-to? Don't make that decision tomorrow when you look at the test. All right, go through each figure and say, how would I do it and what formulas would I need? Also, speaking of the formulas, distance, slope tomorrow. All right, I'm not going to give those to you. Those are on your own. All right, anything else you want to ask going in? A lot of properties. Just know them. All right, bottom line, just know them.
I have a question.
Yeah, sure, Matt. What's up?
So if there's something that like looks a lot like a diagonal, but doesn't say it's a diagonal,
Looks like a diagonal. It's got to connect 2 non-consecutive vertices. Like if you have, like I think on your quiz, no, but I don't think anybody, maybe one person or 2 fell into the trap. But I think on your quiz, I had 1 diagonal drawn in, and then I had this bad boy here. That's not a diagonal. It's got to connect 2 non-consecutive vertices.
what does it say it's a diagonal?
Sometimes it will, but if it connects 2 non-consecutive vertices, you can say it's a diagonal. All right. Anything else? Okay, 3 places I want you to make sure you look at: the 28 questions in the back of your packet, some of which you did last night for homework. I don't know if you also noticed as you went back to the review, there's flow charts with all the properties on there. Okay, that's a good study guide. And then finally, I posted a extra review on Classroom. For some of you that get nervous when you do multiple choice, that review on Classroom, all totally multiple choice. Right, so if you want some practice with some multiple choice with quadrilaterals, that's on Classroom. All right, last call. Anything from you guys before I let you go? All right, let's do this.